Okay, so example 6, graph a polynomial function. So we're given the function f of x and it's in factored form. So the first thing we need to do is to apply the lead-in term test. So if I was to look at my function, so we have, just rewriting the function down. So x multiplied by 2x squared, and we got x multiplied by x. So this would give us 2x to the 4. So this is our lead-in term. So the lead-in coefficient is 2, and the degree is 4. So the graph is positive. And it is also even. So I'm just going to sketch my graph. So this is going to look something like this. And how do I know? Also, I know about the turning points. So the turning points on my graph, the maximum, okay, so the maximum is going to be the number of degrees, that's 4 minus 1, so 3. So I've just sketched 3 turning points. Now, I'm going to decide the limits. So the limit, so as x is approaching negative infinity, so as x is approaching negative infinity, f of x is approaching positive infinity. And as x is approaching positive infinity, f of x is approaching positive infinity. Okay, so the second thing we need to do, we're asked to determine the zeros and to state the multiplicity, which means how many are repeated, of any repeated root So I'm going to rewrite my function. So we have x and then 2x plus 3 and x minus 1, which is squared, so x minus 1. So we have, so let's make this equal to 0. So we have a root at 0. So 2x plus 3 is 0. So x is 3 over minus 3 over 2, which is minus 1.5. And we have x minus 1 is 0, or x minus 1 is 0. So this is your repeated root. So x is 1 and x is 1. So we have a repeated root at x is 1. So to answer the question, determine the zeros. So the zeros are at 0, 1, and minus 1.5. Okay, and we have a repeated root, or a multiplicity of 2 of a 0 at 1. Okay, in part C, choose the x values that fall in the intervals determined by the zeros of the function. So we have an interval between negative infinity and negative 1.5, and negative 1.5 and 0, 0 and 1, and we have 1 and positive infinity. So the x value that we can choose in between, so we're choosing -2, -1, 0.5 and 1.5. So the f of x, so we're going to replace the x with these values so we can find our points. So now we're going to plot these extra points, and the last thing we're asked to do is to graph the function. So I'm going to do this using Desmos. Okay, so entering my function into Desmos and then adding the additional points to my table. So you can see that the points have been plotted. So I'm just going to highlight these points. Okay, so I have these are the points that have been plotted, and my zeros so let's see if I can make this graph a bit bigger. Okay, so I have minus 1.5, 0, and then I have my root at 1. So this here is repeated, and you can see that it doesn't cross, it actually increases.